Alright, hello everyone, it's Mr. Coach. I'm going to go over practice quiz 2. First off, we're estimating these, and the first one says f of 2. And let's see here, 2 is right about there, so we have this point here. And the output value is 3, and if I draw this tangent right here, I have a slope of 3, because it's about up 1, 2, 3 over 1, 1, 2, 3 over 1, and that's a pretty good estimate of the slope. Up 3 over 1 shows how that slope is going. Well, f of 12, well, that's right here, and that's input 12, output 12. And this slope right here is the tangent, and a pretty good estimate is down 3, 1, 2, 3 over 2, and that's about right there. Down 1, 2, 3 over 2, so that's a good estimate of the slope. The secant line is from point to point, right there. And the slope of that one, it's about up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2 is pretty good. Now the secant line, number C, this is the mean value theorem here, which says there's a point where if I draw this tangent that's parallel, it's going to touch this line right here at one point, and it's right there. And that's these two lines are parallel, that's the point, and where is this value? If I drop this value down, to me it looks like it's right at 7. So those are estimations. We have a function here, which is negative x squared over 4 plus 4x. That's the function that gave this graph up here. And if I take the derivative, I have f of x is equal to 2/4, which is a half, negative x plus 4. And now I can, for this value, I can take this 2 and plug it into this first equation, and it'll give me an output of 7. And I can take this 2 and plug it into this derivative, and it will give me right here negative 2, negative 1 plus 4 is that output. So if I plug in 2 here, I have a negative 2 over 2 plus 4, which is a negative 1 plus 4, which is a slope. Same thing with plugging in 12. So you get the values here by plugging into the initial equation. You get the derivatives values by plugging into the derivative. What is the slope? Well, that's the slope of the secant line. Well, that's, we take the, from 2 to 12, the output, it went up 5 over 10, which is 1/2, which is exactly what I guessed down here. If you take a look at that guess, those should be close, and I just got lucky here, they're exact. And right here, find the values. This again is the mean value theorem, where you find the one value on this line where the slope matches, and that's 7. So if you look at these, I guessed, you should get pretty close. All of them were pretty close except this one was off right here, which is fine. Those are all reasonable answers. Number 3, here's a function. We have a relative max and a relative min. So a relative max at negative 220, a minimum here, and it looks like it's decreasing from negative 2 to 1. It's going down, and it's increasing from 1 to infinity. So it's increasing here. I'll put this on green for you here. These are the increasing intervals. Those two intervals, and they're right there and right there. And the other interval we have is a decreasing. I'll put this in blue. Here's the decreasing interval right there. So there's a decreasing interval, and we have those two parts. Alright, and how do you do that with the first derivative test? Well, you take the derivative, which is there, set it equals 0, and find the points, and those are your critical points right there. And then you can take any value you want here and plug it into this and test it out. Now, there was no points of where the function is undetermined, so these are our only critical points. Alright, on the second page, we have a function, and we're using the mean value theorem to find it. So we take this, and here's the derivative. I pull down the 1/2, subtract it, multiply it by the chain rule here, and the slope right here is 5/9. Solve this equation. Now, whatever you can do to get from here to here is fine. There's a lot of ways to simplify and make stuff easier. I mean, I cross multiplied here, and I got this to be 10, right? This would have been 10, and this would have been 45. But then I turned around and just divided it by 5 again. So if you divide it by 5, you're back to 2 and 9. Another rule you could say is that if the numerators are equal, the denominators have to be equal in your fraction. Solve this, and you get 17/4. On this one here, we find the critical points, solve the equation, and have these values. Factoring here, just guess and check to get down to here. To test this, though, one note here, you must plug it into this form, because this is the initial form of the equation here. You can't plug it in down here. You would have to take this up here and factor out a -1 and get 3x squared plus x minus 5. Whoops, that would be plus 5. And now that would be 3x minus 5, x minus 1. If you're testing these critical points, you have to test it into this version, which is a complete version of the derivative. This is a simplified version of the derivative. This is good for finding points, not for testing the arrows. The intervals here are, or the critical points here, are the numbers that make this 0, which would be 2, and the numbers that make that 0, which would be 0. So always you have to, both of them are tested for the derivative, 0 and 2, test the points. I wrote my notation like this, like I plugged in a number -5,000, that makes my numerator negative, makes my denominator negative. Negative divided by negative is a positive, negative divided by positive is a negative, and let's say I plugged in 1,000,000, well that would be positive over positive going up. Increasing, increasing, decreasing. The derivative here, remember it's 3 parts. If you want to take the derivative of absolute value, it is leave it alone, put the absolute value on it, and chain rule. And again, what are my critical points? Well, what makes this 0? What makes this 0? Those are the critical points. Plug them back in to this equation to get the outputs here. The last one, when's the instantaneous rate of change equal to the average rate of change? Well, that screams main value theorem. Find the slope is 3, set it equal to the derivative, and you're done. Number 10, determine all the values for C which satisfy the conclusion of the mean value theorem. Well, here we go. We take this, we solve it, set it equal to 0, and we have 2 answers on here, which means if I have this kind of secant line that looks like this, the graph's going to have 2 matching tangents. Maybe one on the top, one on the bottom, but it's going to have 2 matching tangents to this at 4. Alright, hope this helps with the test.